When we are sick, we will be given a prescription to take medicine from the doctor. Do you know that the medicine that we take is also considered a drug that can cure your illness? So now, let me tell you about the introductions of applications of chemical analysis in drugs. Chemical analysis plays a crucial role in the pharmaceutical industry, ensuring the safety, efficiency, and qualities of drugs. This process involves a variety of techniques aimed at identifying and quantifying the chemical components present in the pharmaceutical substances. In drug development, chemical analysis helps researchers identify promising compounds and understand their molecular structures. Techniques such as spectroscopy, chromatography, and mass spectrometry are used to elucidate the composition of potential drugs and assess their purity. This is vital to ensuring that new drugs are both effective and safe for use in patients. Furthermore, in pharmaceutical research and development, analytical techniques are employed to study drug stability, determine shelf life, and investigate the effects of storage conditions on drugs formulations. This data helps pharmaceutical companies optimize their products for efficiency and safety throughout their life cycle.
Okay, for theory, the first one is drug discovery and development. Chemical analysis techniques are used in the early stage of drugs discovery to identify and characterize potential drug candidates. The second one is formulation development. Chemical analysis is essential in formulating drugs into dosage form suitable for administration. Techniques such as chromatography and spectroscopy are used to analyze the composition of drug formulations, ensuring uniformity and stability. Next, regulatory compliance. Regulatory agencies such as the US Food and Drugs Administration, which is FDA, require extensive chemical analysis data as part of the drug approval process. The last one is stability testing. Chemical analysis is used to assess the stability of drugs under various storage conditions. That's all.
Next, we will move on to methodology for chemical analysis in drugs. There are several common drug analysis methods that we can do, but in this video, I will only explain 3 common drug analysis methods, which is gravimetric analysis, acid-base titration, and chromatography. Gravimetric analysis is the common chemical method in drug analysis and testing. It is the technique in which the amount of analyte in a sample can be determined by converting the analyte to some product where mass of product can be measured. According to different separation methods, gravimetric methods are usually divided into precipitation, volatilization, electrogravimetry, and thermogravimetry. The accuracy of the analysis result is also high. Next is acid-base titration is a widely used chemical analysis technique in real-world production. Acid-base titration is typically used to determine the amount of the primary ingredients in various industrial products such as caustic soda, soda ash, ammonium sulfate, and ammonium bicarbonate. Acid-base titration is to drop a reagent solution with a known accurate concentration into the solution of the tested substance until the chemical reaction is complete. Researchers can determine the content of the measured component by measuring the volume and concentration of the reagent solution. Last but not least is chromatography. Chromatography, also known as chromatographic analysis, is a method and means of separation. It is mostly accomplished by the selective dispersion of various substances in various phases. The mobile phase of the mixture, which is present in the stationary phase, perform the elution operation, causing the various substances in the mixture to move at various speeds and eventually generating the separation effect.
Hi, I am Akila. So now we are moving on to the example application. As mentioned in the previous slide, there are few methodology for application of chemical analysis in drugs. However, we decided to give one example from the acid-base titration method. By using acid-base titration, we can determine the purity of aspirin in a given drug sample. Aspirin is a common drug for relieving minor itches, pain, and also the fever. So the first procedure for titration is sample preparation by weighing the sample and then dissolve it in the water. Next is hydrolysis, and then you can start to titrate the excess NaOH with HCl. Lastly, use phenolphthalein as an indicator. Okay, now it is time for the calculation. Mind you, the value given is not a real value of the sample. It's just an example. The first step of calculation is you have to find the initial mole of NaOH, and then the second one, calculate the remaining mole of NaOH by using the ratio HCl 1:1. So it just equal HCl mole and also the remaining NaOH mole is the same. Third, determine the moles of NaOH reacted with aspirin by subtracting mole initial with mole remaining. The fourth step is determine the mole of aspirin. This one we can use ratio 1 mole of aspirin to 2 moles of NaOH. When you got the answer, you can find the mass of aspirin by using formula mass equal to mole times molar mass. Lastly, you can get the purity of aspirin. Just divide the mass obtained with the mass given and then times with 100. Okay, there you go, 72.06%.
Next, for conclusion, the application of chemical analysis has transformed drug development and quality assurance practices by providing crucial insight into drug compositions, purity, and performance. Advanced analytical techniques have not only enhanced our ability to detect many impurities, but also supported the formulation of more stable and bioavailable drug products. Moreover, chemical analysis plays a pivotal role in regulatory compliance, ensuring that pharmaceutical meets stringent safety and efficiency standards. Looking ahead, continued advancement in analytical methods promise to further improve our understanding of drug formulation and facilitate faster, more reliable and quality assessment. In essence, chemical analysis remains indispensable in safeguarding the integrity and effectiveness of pharmaceutical products, contributing significantly to advancement in healthcare worldwide. That's all from us. Thank you.